Welcome back. In this video, we'll cover the last two measures of dispersion, which are called the variance and standard deviation. Let's start with the variance. The variance is the average squared distance to the mean. It's not typically used as a measure of dispersion, but it's useful in certain situations. In the last video, we talked about the mean absolute deviation, or the MAD, which is the average distance to the mean. We learned that each data value has its own distance to the mean, called an absolute deviation, and the MAD is just the average, or the mean of the absolute deviations. If you take each absolute deviation, or each distance, and multiply it by itself to get a squared deviation, and then you calculate the mean of all of the squared deviations, the answer is called the variance. Let's go over the steps to find the variance of a set of data. The first step to find the variance is calculating the mean of the data. The second step is subtracting each data value by the mean to get deviations. The next step is squaring each deviation, or multiplying each deviation by itself. The next step is adding the squared deviations. And the fifth step actually depends on whether the data comes from an entire population or from a sample. If the data comes from an entire population, you divide the total by the number of squared deviations. If the data comes from a sample, you actually divide the total by one less than the number of squared deviations. The formula has to be adjusted slightly if the data comes from a sample. We'll go over an example of how to find the variance with data from an entire population, and an example of how to find the variance with data from a sample. This first example says, a population of 4 people have the following numbers of siblings, and what is the variance of the data? This data came from a population, so we'll be following the steps to find the variance of an entire population. First, we calculate the mean of the data. We add these 4 numbers and divide the total by 4. Next, we subtract each data value by the mean of 6 to get our deviations. Next, we square each deviation. In other words, we multiply each deviation by itself. -4 times -4 is 16, because when you multiply a negative by a negative, it becomes a positive. -1 times -1 is 1. Once again, the negative signs cancel out. 1 times 1 is 1, and 4 times 4 is 16. Once we get the squared deviations, we add them to get a total, and then we divide by 4, which is the number of squared deviations. And then our answer is the variance. Notice how the variance is just the mean of the squared deviation column. Just like how the MAD is the mean of the absolute deviations, the variance is just the mean of the squared deviations. The MAD and the variance are just two different types of means. This example says a sample of 4 people have the following numbers of siblings, and what is the variance of the data? In this example, the data came from a sample, so we'll be following the steps to find the variance of a sample. First, we add the data values and divide by 4 to get the mean. Next, we subtract each data value by the mean to get our deviations. Next, we square each deviation, or we multiply each deviation by itself. Remember, -4 times -4 is 16, because -4 times -4 is really just 4 times 4. -1 times -1 is 1. -1, that's because -1 times -1 is really just 1 times 1. 1 times 1 is 1, and 4 times 4 is 16. Once we get the squared deviations, we add them to get a total, and then we actually divide by 1 less than the number of squared deviations. Instead of dividing by 4, we divide by 3. Whenever the data comes from a sample, this number that you divide by has to be dropped down by 1. And our answer, after dividing, is the variance of our data set. So we looked at how to find the variance of a population and how to find the variance of a sample. Let's now look at the next measure of dispersion, which is called the standard deviation. Well, first let's go over a few important points about the variance. It can only be calculated with quantitative data. In other words, it can only be calculated with numbers like heights, ages, or incomes. It can't be calculated with category values like genders or hair colors. Second, it comes out to a larger number when the data has more dispersion, just like the MAD. Any measure of dispersion comes out to a larger number when the data has more dispersion. It isn't commonly used as a measure of dispersion, but it is used in some situations. The next measure of dispersion that we'll talk about, which is the standard deviation, is actually the most commonly used measure of dispersion. Let's now talk about the standard deviation. The standard deviation is just the square root of the variance. To get the standard deviation, all you have to do is calculate the variance and then go one step further and find the square root of the variance. These are the steps. You calculate the mean of the data, you calculate the deviations, you square each deviation, you add the squared deviations, and then you do step 5, which depends on if the data is from a population or from a sample. After you finish step 5, you have the variance, and in step 6, you find the square root of the variance to get your standard deviation. We'll go through an example of finding the standard deviation of a population and an example of finding the standard deviation of a sample. This example asks us to find the standard deviation of a population of 4 people. So we go through all of the same steps to find the variance. We add the squared deviations and divide by 4. Remember, we're dividing by 4 because it's a population. We're not dropping this number down by 1. Once we get the variance, we find the square root, and then that's the standard deviation. To find the square root, you have to use a calculator that has a square root key. This next example says a sample of 4 people have these numbers of siblings, and what's the standard deviation of the data? Once again, we go through the steps to find the variance. We drop this number down by 1 because it's a sample, and once we get the variance, we take the square root of the variance and we get our standard deviation. So the standard deviation is just an extension of the variance. To get the standard deviation, you find the variance and you go one step further. Here are a few important points about the standard deviation. First, it can only be calculated with quantitative data, just like the MAD and the variance. Second, it comes out to a larger number when the data has more dispersion, just like the other measures of dispersion. Third, it comes out to a number close to the MAD. When the MAD and the standard deviation are calculated with the same data set, the two answers come out to about the same number. That means that the MAD and the standard deviation are really roughly the same concept. The MAD is the average distance to the mean, and you can think of the standard deviation as just a number that's roughly close to the MAD. And finally, it's the most commonly used measure of dispersion. If you read about an actual research study, you'll probably see the mean and the standard deviation reported together.